All right, your first one that I want you to work, the derivative of the inverse sine. If you got to take a look at it, go ahead and take a look at it, of x squared. Now, this is also the arc sine of x squared. Now, yeah, you're going to do the chain rule. Here's what you want to do. Our rule has the u's in it, and if you look at the rule sheet that you have on the inside cover of your handbook, everything's in terms of u because everything's in terms of the chain rule. Now, I could have just told you that, hey, everything's there, and you could have just looked at it, and you have to know numbers 1 through 24 and 1 through 18, but I wanted you to write them down. And just so I'll be honest, it's one of the things I used to do is to help memorize, I had to write them over and over again. So having you guys at least write them once, I think could help, because then that movement of your hand, it makes a connection to your brain. That whole, and as we can see over there, he's trying to connect his brain to the desk. There he is. Now, whenever you're working with these and any other functions, what's my u value? It's x squared. So what's u prime? 2x. Now, if we go to our rules, the derivative of the arc sine is what? Alright, u prime over 1 minus the square root of 1 minus u squared. So I'm going to go and say, alright, it's u prime, so it's 2x, divided by the square root of 1 minus u, what's my u value? X squared squared. Yeah, so it'll be x to the fourth. So it's 2x over the square root of 1 minus x to the fourth. Was that horrific? Well, it might be the first time you see it and the first time you're playing around with it. But trust me, it gets better the more you do it. Power to power is, yeah, what she said. Yeah, well, but it does. It does matter. It's 2 times 2. Because it's like, remember, it's like x squared times x squared, which is x, which is x to the fourth. If it was x to the third, it'd be x squared times x squared, then you get your 6 from there. So when in doubt, always go back to the definition of what you're doing. If your brain locks and you don't remember how to do that, go back to the definition of what this actually means. Yeah, if you're multiplying like this, it'd be 2 plus 2 plus 2. Alright, another example. F of x is equal to the cotangent of 3x squared plus 2x, or 3x cubed plus 2x squared. What's my u? So what's my u prime? Nine x squared plus 4x. Alright, so if I'm going for f prime now, yeah, we're doing the inverse. So we're doing the arc cotan. So we look for that guy, and it's negative u prime over 1 plus u squared. So What was u prime? Nine x squared plus 4x. And this is going to be 1 plus u squared 3x cubed plus 2x squared quantity squared. Now you could go one step further and say negative 9x squared plus 4 or minus 4x all over 1 plus 3x squared plus 3 distribute the negative 1. You could have kept it just like this. This would have been acceptable to me. But I just said if you wanted to take it one step further, and then I screwed it up.
So we have to like expand the bottom?
Oh God, no. God, no, no. Don't do that. Why would you want to?
I don't want to get on what you want.
It's better to keep it like this because it's not necessarily in factored form, but it's in a better form to deal with. Especially if we have to find critical values and all this stuff, or if we have to find domain and range, we can find out where this is going to be 0, or maybe it never is going to be 0, that type of stuff. Aha, here we go. This one's going to be an interesting one for you. Take a look at your rules. Whenever you see something like this, where it's something over like x times the square root of something, instantly start thinking about arc sines, arc cosines, arc tangents. And which one has like a function times the square root of u squared minus something squared? Yeah, okay, so this is going to be the arcsecant. But we have to make sure that everything is in order. Now, the 4x squared, this is equal to u squared. Do you agree? Because this should be, the integral is du over u times the square root of u squared minus a squared. Alright, so what's u? If u squared is 4x squared, what's u? 2x. Now, do I have 2x here? No. That's a problem, isn't it? That's exactly what we're going to do. Nice job. Now, the thing is, if if this was perfectly set up, I should see du, and I should have 2x times the square root of 4x squared minus 1. That's what I should see. Do I see that? Okay, so we don't have this. So I need a 2 times x. If I have a 2 times x, then I can use the rule, right? Now, what is the one math rule that is the most powerful math rule in existence? Multiply by variations of 1, which is what Lauren said. So I can multiply this by 1, but I'm going to multiply this by 1 by saying, call it 2 over 2. What's 2 divided by 2? 1. So 2 divided by 2 is equal to 1. If I multiply this integral by 2 over 2, am I multiplying it by anything that's going to change anything? No. So now I can rewrite this as 2 times the integral of, I could put dx up top to make it look all like the rule. This would be 2x times the square root of 4x squared minus 1. I already know my u is 2x. What's my a? This guy, remember, right here is a squared. A squared is equal to 1, so a is equal to 1. So now it's just an application of the rule. So it's going to be 2 times 1 over a. So it's 1 over 1 times the arc secant of the absolute value of u. So what was my u? 2x divided by a, which is 1 plus c. So I'm just going to, in a different color here, put that's an a, that's an a. Now, what's 1 over 1 times 2? 2. So this is 2. We just have to do cleanup now. And it's 2 times the arc secant. Now, what's the absolute value of 2x divided by 1? Absolute value of 2x. Don't lose the absolute values. Plus c. The rule is 1 over a times the arc secant of the absolute value of u over a plus c. That's what the integral should be. Over 1 is just going to be the absolute value of 2x. The 2's out front, so we leave it out front. And this represents the angle. And it says that whatever the angle is, it's going to be positive. Yes? How did I get this? Oh, because I figured out that this represents u squared right there. The 4x squared represents u squared. So I set it up here, and I found out that u is equal to 2x. But in the original problem, I just had an x. So I needed to have 2x there to apply the rule. So I said, all right, well, in order to apply the rule, I got to go 2 over 2. I have to multiply this by 2 over 2 because 2 over 2 is 1. And that makes the 2x that's going to be there. And I just pulled that 2 from the numerator out front because I'm not going to, that doesn't do anything for me inside. And it doesn't really set it up to be the actual formula. So once I have the 2 times the integral, I do the integration and I get this value. Now, I want to show... Have I confused you enough yet?